All right, good afternoon, everybody. I've actually been meaning to make it out to iOS Conf Singapore for like 3-4 years now, so I'm quite happy to be here in front of you today. So yeah, we'll be going through a quick introduction to interactive widgets. As Janina mentioned, I work as a developer advocate at Vonage, but that's enough about me. Let's just get straight into it. So you may be asking what an interactive widget is. So before we dive into that, we first must ask what a widget is. And to answer that question, we have to go back a very, very, very long time ago to the invention of the widget at WWDC 2020. This is where, on a bright summer morning in Cupertino, we were introduced to WidgetKit as part of iOS 14. Although widgets were previously available in the Today view, these new widgets are now on the home screen, they're configurable, they're available in a range of different sizes, and I think they look a bit better. And they're also powered by SwiftUI, so that's a big plus. But you might be asking, how do these widgets work? And unfortunately, not by magic, but they use the next best thing, which is a widget extension. So these are ran by the system in a separate process from your application. So you add them to your Xcode project as if you add any new target. And inside your widget extension, you will have a struct which conforms to the timeline provider protocol. And in your timeline provider protocol, you will have a function which returns a timeline of entries. So let's go through an example together. Very conveniently, I've entered a Daft Punk album tracklist memorization contest, and I've built a widget to help me come home with the gold. And as you can see, design is a passion of mine, so I've made some lovely diagrams to help explain what's going on here. Well, doesn't show up very well, but on the left there, you have the system or WidgetKit. I'll use both interchangeably. This requests a timeline of entries from your timeline provider. Then in your timeline provider, you create an array of entries which are just structs which conform to the timeline entry protocol. So in this case, I've created a struct for 1 p.m., 2 p.m., 3 p.m., and in there I have a property called song title, ... which will vary in each one of these entries, and I create an array of that, and I return that. Then these entries are essentially used as a way to get data into your widget view. So you create a struct, which is just a SwiftUI widget view, and in here you can use the data from your timeline entry. So you can see I have a text there, which is using the song title from my timeline entry. But here's the super cool part. So WidgetKit actually archives your view hierarchy and saves that to disk. And when it's time to actually show your widget on device, it actually grabs the archived view hierarchy, renders it just in time, and shows it. So quite fancy, but you have to remember that your code only runs in this archive stage. It doesn't run when your widget is actually being shown to a user. But not to worry. WidgetKit handles that all for you. You don't need to worry about that. You just need to create your array of timeline entries, and you need to build your widget view. So here's a quick sneak peek at my timeline provider class, and this is how I'm creating my timeline. If you can look to the part that says look here please, it's a for loop, which I'm creating some entries, I'm appending them to an array. Then on the final line there, I am just returning a timeline of my entries. Then if we look at my actual SwiftUI widget view, very simple, just a VStack with the album name and the song title. And great, that gives me exactly what I want. I have the album tracklist shown on my home screen, and I can practice wherever I may be. You can also manually reload widgets from your app if you're calling the reload timelines function. And this takes a kind of widget as a string, so you can give a widget a kind, and that way you can reload specific widgets depending on what's happening in your application, so you don't have to reload all your widgets, because that will be quite wasteful. In addition to that, when you're returning your widgets from your timeline provider, you can also specify a reload policy. So you can specify whether to reload at the end of the entries you've given. So in my case, at 3 p.m., it will say there are no more entries, let's reload the widget. You can say never, so this is a static widget, never reload my timeline. Or you can say reload my timeline after a very specific time and date. But again, it's very important to note here that the system decides when to reload your widget. You can suggest and say, hey, please, at 4 p.m., please reload my widget. But depending on what's happening on the phone, that may just not happen. So again, for example, if someone was in low power mode and the phone wants to conserve energy, it just won't reload your widget, or it will save it for a later date. But when your widget does get reloaded, it does that whole process again. So back to the initial lovely diagram that I showed you, you create an array of timeline entries, you return those entries to WidgetKit, which gets used in your view, and it gets archived, et cetera, et cetera. For brevity's sake, we will call that the create and return timeline step. We'll be going back to this, so just that's that step there. Cool. So we know how a widget works. Let's take a look at an interactive widget. So again, on a bright summer morning from Cupertino, this one actually happened in real life. In WWDC 2023, we were introduced to iOS 17, which showed us some interactive widgets. So as you can see, there's the home widget there, which allows you to toggle on and off lights. There's the reminders widget as well, which allows you to tick off items. And you even have Overcast there, which allows you to start playing a podcast directly from your home screen. But how does interactivity work? For a normal widget, we have this create and return timeline process, which we now know and love. But as I mentioned, your widget code only runs during that archive step. So let's head back to our example. I want to be able to learn the album track list a bit faster, and I would much prefer to be able to skip a song rather than waiting a whole hour for the next song to show up. And the solution for that is app intents. So app intents was introduced in iOS 16, the year prior, which is more of an evolution of the intents definition file if you've ever used it before. But this essentially exposes actions your app can perform to the system, and the system can run those whenever they want. Then in iOS 17, some additional initializers were added to button and toggle to allow you to use an app intent instead of the typical action you may be used to. And there was one key piece of information: interactions from a toggle or a button always guarantee a timeline reload. And if it doesn't, you can file a raider. But this is quite a large departure from the previous slides, where the system may reload your widget whenever it feels like it. So cool. Let's take a look at my intent for going to my next song. So again, this is a struct which conforms to the app intent protocol, which requires you to have a title for your app intent. Then on my app intent, I've implemented the perform function. The perform function essentially gets called when your app intent gets called. It's an asynchronous function which returns some intent result, if you're familiar with the new generic stuff. But as I mentioned, it's asynchronous, so you can run off and do potentially a network call. You can make a call into core data, Swift data, essentially, etc. I'm making a call into my totally real database, which is so good that it works synchronously. But then the key part to remember here is to finish all your processing, etc., before you call the return result. Because the second you call the return result, WidgetKit will reload your widget's timeline. Here's the intent in action: is Swift UI button, as you're familiar with, but instead of an action, I'm using an intent. And if we go back to our widget, you can see I have my next and previous buttons. The previous song intent was a copy and paste job, but it does a -1 instead of a +1. So just as a high-level overview of how that works, so you have your interaction. So this is a button or a toggle. That in turn calls your app intent's perform function. Then once your app intent perform function returns, the system or widget kit will reload your widget's timeline. And it's a key thing to remember, this timeline reload works exactly the same as when we were initially creating our widget or for reloading the widget from our app. It's the same process. Widget kit just calls the timeline function on your timeline provider. So you want to make sure that when your timeline provider is called, it's basically calling from a fresh data source rather than any stale data. Otherwise, you won't get the illusion of an interactive widget. So if we take a look back at my timeline provider, you can see the first thing I'm doing here is I'm making a call into my database to get the album name. So for example, if I had an intent or a button, sorry, to change the album, in my intent, I would make a call into my database to say the new current album is XYZ. That way, when my timeline reloads, it says, okay, the album is XYZ, then the rest of the code is conditional on that new piece of data. And as I mentioned, the perform function is asynchronous, and because you can have a long-running process in there, you have a way to basically signify to users that stuff is happening rather than nothing happening and them spamming the button, etc. So to do this, you have a property modifier on a SwiftUI view called invalidatable content. So this essentially lets WidgetKit know that whatever happens in my intent may potentially affect this view, so animate it with the flashing. That way there's a nice, fun interface for the user rather than nothing at all. You also have the ability to use the SwiftUI animations you're familiar with. So in my next button intent, I added a 3-second delay. Don't worry, my database isn't that bad. But you can see I have the, I've just chained on a SwiftUI animation there at the end. Cool. And as I mentioned earlier, the toggle control also gets all the same benefits we get on the button. So here I have a toggle which is just showing and hiding the album name, just in case I wanted to make my life a bit harder when I'm memorizing the tracks. And here's a look at the intent for the toggle control. So the intent works exactly the same as any other app intent. So this could have been a button. It's not really, it doesn't really matter. But I've gone a bit further this time. So I've added a parameter, hide album button. So that's a Boolean. And if you want to add a parameter to your intent, you have to use the @parameter property wrapper for reasons, which we will find out later. Then you can add your initializers, and you can pass through your value and use that in your perform function like you would any other code. And here is the intent in action there. Cool. And here's another cool thing that WidgetKit does for you. So if you look carefully, I'm tapping the toggle button, and it immediately toggles to the opposite state rather than waiting for my perform function to return to toggle off. So you can see the flashing is still happening, so my perform function hasn't returned, but the toggle is actually switched to the opposite state. So WidgetKit actually archives your view with the toggle on and with the toggle off. That way, if someone presses a toggle, that instantly flips over. So you can think, for example, if you had a shopping list app, you've picked an item off the shelf, you mark the item as complete. You don't really want to wait for a database call or a network call to say, oh, I've ticked off this item. That's quite like a bad user experience. So because both the toggle on and off has been archived, that immediately happens. That way there's instant feedback. Then hopefully when your perform function returns, your data is consistent and there's not really much of a difference. So it doesn't toggle on, then back off. Cool. So a few things to watch out for when you're building an interactive widget. The first one is, I guess, if you're tapping on a button or a toggle too fast, it actually registers the tap as you tapping on the widget, and it opens your app. So yeah, I've tapped next too quickly there, and now it's opened my app. You can handle where your app opens to by using the widget URL modifier here, and this uses deep linking, just like any other system opening your app. But a cool thing is that you can actually specify which part of the widget deep links where, so you can add the widget URL modifier to different parts of your view. So for example, if I tapped on my whole widget by accident, I can go to a screen that says, oh, close the widget, close the app and get back to the widget. Or if I tapped on the album name, for example, that will go to like an album detail screen. Another thing to worry about is that widgets also have a 30 megabyte memory limit. So if you're building something super fancy, I'll show you some examples later, you kind of need to watch out for this. And there's not really much you can do about those two things. Cool, so we have our widget, it's working. So let's look at some of the free stuff we get for building a widget with iOS 17 and app intents, because we all love free stuff. The first thing you get is your actual intent that you've built. So you can actually use your app intents in your main app target. You can just compile for both your app target and the widget extension. And if you import SwiftUI and the app intents framework, the new initializers for button and toggle will be available. So you can actually reuse this code. So it's not just wasted work or just work for your widget. You can actually use it in both places. And a fun fact, if you want to build interactive live activities, so if you want a button on your live activity, that also uses a sub-protocol of app intents, so that code is also reusable there. The super fun part is that if you add a perform function to the app intents protocol, if you add a perform function to your app intent, this app intent is automatically exposed to the Shortcuts app. So here is my toggle app intent from earlier in the Shortcuts app. And you also have different app intent results you can return. So if you remember earlier, we were using the intent result return type. You can also use provides dialog, returns value, and show snippet. I don't want to go into a full rant about app intents, but I'll show you quickly how you can use provides dialog rather. So this is actually an app intent from one of my unreleased, unfinished side projects. So it's an app that shows you train times at a specific tube station back in London. And since I'm already doing all the work to get the latest arrivals at this train station, I might as well create a human readable string, which is what I'm doing there, like arrival string equal generate arrival string. Then I can just return that in my result as well from the intent, and you sort of get this cool behavior. So you can say, hey Siri, when's my next train? And it will, she'll speak back to you, and you can, have a hands-free process for your app. And again, that was done with not too much extra work, just a few lines. And here's our toggle album intent from earlier. So as I mentioned, like the reason you have to use the app parameter and you have this empty initializer is that your intent still works with the Shortcuts app. So as you can see, like the properties in the intent code and what you can see in the Shortcuts app sort of map one-to-one. So the Shortcuts title is toggle album as well, and the name of the Boolean is hide album name. But this intent I sort of built just for use in my widget. It's not really useful for the Shortcuts app. So you can add the is discoverable Boolean. You can set that to false, and that will stop that auto shortcuts behavior from happening. Also, if you're using macOS Sonoma, you can add iOS widgets to your desktop and your notification bar. And the interactivity works just as you expect. My understanding is that this sort of, I guess, streams stuff to and from your iOS device. So it's quite important if you're to make sure you're using invalidatable content on your views, because there'll be a bit of latency there compared to just doing it on your phone. Also in standby mode, so if your widget uses the small widget size, you can have your interactive widget available in standby mode. Cool. So I appreciate the example I showed you today was quite simple and completely made up. So I've gathered a few interactive widget examples I found on the internet just to give you an idea of the stuff you can build with it. So this is the Overcast app from earlier, so you can start playing audio straight from your home screen. This is a shameless plug for me. So this is the widget for my app. So this is the train times. Then I have a little refresh button there, which allows you to grab the latest times. You have a get sum here, which is a great use of the toggle option, so you can toggle items off as you're shopping. Then, yeah, we have a classic widget games, which has gone all the way out and brought, Connect 4, chess, etc., directly to the home screen. So it's super impressive. Then it's even more impressive considering the 30 megabyte memory limit as well. Similarly, of course, I had to put Pixel Pals up there. I think Christian built like a full-on platformer game, which you can see on the top, which again, super impressive considering the 30 megabyte memory limit. I'll leave you with some words from Daft Punk. I'm very excited to see what interactive widgets you build, and thank you for listening.
Wow, Abdul, thank you so much. That was fantastic. We have time for just a couple of questions. So does anybody have any questions about widgets? Well, that just speaks to how comprehensive this was. So if you do have questions, as always. Okay, there we go.
Always have a question. So one of the things announced at DubDub this year was having iOS widgets on the macOS desktop. Have you played around with that at all?
Yeah. I mean, played is a strong word. It kind of just works as long as the iOS app has your widget available, and I guess you're logged into the same iCloud. You can just open the notifications drawer on macOS. There's a plus now, and it should show up there, hopefully. But yeah, it just works.
I have a question actually. So how does the system handle if your widget is using too much memory? What happens?
I haven't seen the exact behavior, but I've crashed plenty of widgets before. I assume it might just show you the placeholder, or it might not mutate at all. But
okay.
Yeah.
Any other questions? All right. Oh, I see a question over there. Making me do cardio.
Hello. By the way, nice presentation. I have same question. So she mentioned that what if our widget takes more memory, so it will crash. So as you know that widgets are something like when Apple introduced it, they said that it's not a mini app, but as I can see it turning into a mini app. So that's a separate thing. So first thing, suppose some application will want users' attention. So they will try to add as many, like they will push the customer to add as many widgets as possible. Suppose maybe minor widgets on lock screen. And they will try that, suppose we have cell today. So they will try to add some sort of shimmer, and they will try to do API call in the background. So that will also take a lot of memory. So is there any guideline that we can restrict or some kind of thing about that?
Not particularly. I think it's just the usual case of running the profiler. So in Xcode, when you add a widget extension, you can actually run the widget as a separate thing, like in the drop-down at the top. I haven't tried it, but I assume instruments should hopefully work. And you can sort of keep track on what you're doing there. But I think stuff like animations, network calls, I think those are relatively lightweight operations, so I wouldn't particularly worry too much, if that answers the question.
Yeah, just one last question. So can multiple widgets run in the background simultaneously?
Yeah, so that's, I guess, why they went down the whole Swift UI archiving sort of thing. So like once your view code is archived, like iOS can just grab it and render it, like versus the actual building and running your code, which is I guess orders of magnitude probably more expensive versus just grabbing the view hierarchy and displaying it. So.
I'll not waste time. Sorry.